Welcome. Today, we're diving into the world of design patterns in Java. Design patterns are tried and true solutions to common software design challenges. They aren't tied to any specific programming language, but Java developers often rely on them to write cleaner, more maintainable code. In this video, we'll explore what design patterns are, why they matter, and how they help structure your code for flexibility and reuse. Whether you're new to Java or looking to deepen your understanding, this journey will give you practical insights and examples. Let's get started by understanding the basics of design patterns and their role in software engineering. Design patterns are standard solutions to recurring problems in software design. Think of them as templates or blueprints that you can use to solve common issues in your code. Instead of reinventing the wheel every time you face a challenge, you can apply a design pattern that's already been proven to work. These patterns help you write code that's easier to understand, maintain, and extend. They also promote best practices in object-oriented design, making your Java applications more robust and scalable. Now, let's look at the main categories of design patterns and see how they're organized. Design patterns in Java are typically grouped into three main categories: creational, structural, and behavioral. Each category addresses a different aspect of software design. Creational patterns focus on object creation, structural patterns deal with class and object composition, and behavioral patterns manage communication between objects. By understanding these categories, you'll be able to choose the right pattern for the right situation. In the next scenes, we'll break down each category and explore their most popular patterns, starting with creational patterns. Creational patterns are all about how objects are created in your application. They help you control object instantiation, making your code more flexible and efficient. Instead of creating objects directly, these patterns provide various ways to create objects that suit different scenarios. This is especially useful when your codebase grows and you need to manage complex object creation logic. Let's take a closer look at the most common creational patterns used in Java, starting with the Singleton pattern. Singleton pattern ensures that a class has only one instance throughout the application and provides a global point of access to it. This is useful for resources like configuration settings or database connections, where having multiple instances could cause problems. In Java, you typically implement Singleton by making the constructor private and providing a static method to get the instance. This pattern is simple but powerful, and it's one of the most widely used creational patterns. Factory method pattern defines an interface for creating objects, but lets subclasses decide which class to instantiate. This means you can write code that works with objects created by the factory without knowing their exact types. It's a great way to decouple your code from specific implementations and make it more flexible. In Java, you often see this pattern in frameworks and libraries that need to create objects in a customizable way. The abstract factory pattern provides an interface for creating families of related or dependent objects without specifying their concrete classes. This is useful when your system needs to be independent of how its objects are created. For example, you might use an abstract factory to create UI components for different operating systems, ensuring consistency across your application. In Java, this pattern helps you manage complex object creation scenarios with ease. The builder pattern allows you to construct complex objects step by step. It separates the construction of an object from its representation, so the same construction process can create different representations. This is especially useful for objects with many optional parameters or configurations. In Java, the builder pattern is often used for creating immutable objects, like those in the JavaBeans or string builder classes. The prototype pattern creates new objects by copying existing ones, rather than creating them from scratch. This is useful when object creation is costly or complex. In Java, you can implement the prototype pattern by using the clone method. It's a handy way to quickly produce new instances with the same state as an existing object, making your code more efficient and easier to manage. Structural patterns focus on how classes and objects are composed to form larger structures. They help you create flexible and efficient code by defining simple ways to realize relationships between entities. These patterns are essential when you need to build complex systems from simpler components. Let's explore some of the most common structural patterns, starting with the adapter pattern. The adapter pattern allows incompatible interfaces to work together. It acts as a bridge between two incompatible interfaces by wrapping one interface and making it compatible with another. In Java, you might use an adapter to connect a new class to an existing system without changing the original code. This pattern is especially useful for integrating third-party libraries or legacy code. The decorator pattern adds responsibilities to objects dynamically without altering their code. It's like wrapping an object with additional features, allowing you to extend its behavior at runtime. In Java, decorators are often used in input-output streams, where you can add buffering, compression, or encryption to streams without modifying their core logic. The facade pattern provides a simplified interface to a complex subsystem. It hides the complexities of the system and offers a single entry point for clients to interact with. In Java, you might use a facade to wrap a set of APIs or classes, making it easier for users to perform common tasks without dealing with the underlying details. Structural patterns also include other useful designs like proxy, composite, bridge, and flyweight. Each of these patterns addresses different challenges in structuring your code. For example, the proxy pattern controls access to objects, while the composite pattern lets you treat individual objects and groups of objects uniformly. Understanding these patterns gives you more tools to build robust Java applications. Behavioral patterns focus on how objects communicate and interact with each other. They help you manage complex workflows and responsibilities among objects. These patterns are essential for organizing code that involves lots of object collaboration. Let's look at some common behavioral patterns, starting with the observer pattern. The observer pattern defines a one-to-many relationship between objects, so when one object changes state, all its dependents are notified and updated automatically. In Java, this is commonly used in event handling systems, like GUI frameworks. It's a great way to keep different parts of your application in sync without tightly coupling them. The strategy pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable. This allows you to select an algorithm at runtime without changing the code that uses it. In Java, you might use the strategy pattern to implement different sorting or filtering strategies, making your code more flexible and maintainable. The command pattern encapsulates a request as an object, allowing you to parameterize clients with different requests, queue or log requests, and support undoable operations. In Java, this pattern is often used in GUI toolkits and task scheduling systems. It helps decouple the sender and receiver of a request, making your code more modular. The chain of responsibility pattern passes a request along a chain of handlers, allowing each handler to process the request or pass it along. This pattern is useful for building flexible and extensible processing pipelines. In Java, it's often used in event handling and middleware systems, where multiple objects can handle a request. The template method pattern defines the skeleton of an algorithm in a method, deferring some steps to subclasses. This lets you redefine certain steps of an algorithm without changing its structure. In Java, you might use this pattern to implement common workflows with customizable steps, promoting code reuse and consistency. The state pattern allows an object to change its behavior when its internal state changes. It appears as if the object changed its class. In Java, this pattern is useful for implementing state machines or objects that need to behave differently in different situations, such as UI components or workflow engines. The mediator pattern defines an object that encapsulates how a set of objects interact. Instead of objects referring to each other directly, they communicate through the mediator, reducing dependencies and simplifying communication. In Java, this pattern is often used in GUI frameworks to coordinate interactions between components. The memento pattern captures and externalizes an object's internal state so it can be restored later, without violating encapsulation. In Java, this is useful for implementing undo-redo functionality or saving and restoring object states. It helps you manage state history without exposing the details of the object's implementation. The visitor pattern lets you add new operations to existing object structures without modifying their classes. It separates the operation from the object structure, making it easier to add new functionality. In Java, the visitor pattern is often used in compilers and interpreters to perform operations on complex object structures. The interpreter pattern defines a way to evaluate language grammar or expressions. It's useful for building interpreters for simple languages or scripting engines. In Java, you might use this pattern to parse and execute expressions, commands, or configuration files, making your applications more flexible and extensible. The iterator pattern provides a way to access elements of a collection sequentially without exposing its underlying representation. In Java, iterators are a core part of the collections framework, allowing you to loop through lists, sets, and maps in a consistent way. This pattern makes it easy to traverse complex data structures. Now that we've covered the main types of design patterns, let's see how they're used in real-world Java applications. Design patterns are everywhere, from frameworks like Spring and Hibernate to everyday code you write. They help you solve common problems efficiently and make your codebase easier to maintain and extend. Using design patterns in Java brings many benefits. They make your code more reusable, readable, and maintainable. Patterns also help teams communicate more effectively, since everyone understands the standard solutions being used. By applying patterns, you can avoid common pitfalls and write code that stands the test of time. It's important to know when to use design patterns. Don't force a pattern into your code if it doesn't fit the problem. Use patterns when they provide clear benefits, such as simplifying complex logic, improving flexibility, or making your code easier to test. The key is to understand the problem first, then choose the right pattern as a solution. While design patterns are powerful, they can be misused. Overusing patterns can make your code unnecessarily complex and hard to understand. It's important to apply patterns only when they add real value. Always keep your code as simple as possible and use patterns to solve specific problems, not just for the sake of using them. Good documentation is essential when using design patterns. Make sure to document why you chose a particular pattern and how it solves the problem. This helps other developers understand your code and maintain it in the future. Clear documentation also makes it easier to onboard new team members and ensure consistency across your project. Design patterns have well-known names like Singleton, Factory, and Observer. Using these names in your code and documentation makes it easier for others to understand your design decisions. Stick to standard naming conventions to promote clarity and avoid confusion, especially when working in larger teams or open-source projects. There are many catalogs of design patterns available, such as the famous Gang of 4 GoF book. These catalogs provide detailed descriptions, examples, and use cases for each pattern. Exploring these resources can help you deepen your understanding and discover new ways to solve problems in Java. Many popular Java frameworks are built on design patterns. For example, Spring uses Singleton and Factory patterns extensively, while Hibernate relies on proxy and template method patterns. Understanding these patterns helps you use frameworks more effectively and customize them to fit your needs. Design patterns also improve team collaboration. When everyone on your team understands and uses the same patterns, it's easier to communicate ideas and work together on complex projects. Patterns provide a shared vocabulary that streamlines discussions and decision-making. Design patterns can make your code easier to test. By decoupling components and promoting modular design, patterns help you write unit tests and integration tests more effectively. For example, using the factory or strategy pattern can simplify mocking and stubbing in your tests. Some design patterns can improve the performance of your Java applications. For example, the flyweight pattern reduces memory usage by sharing objects, while the proxy pattern can control access to expensive resources. However, always measure and test performance impacts before adopting a pattern for optimization. Design patterns can help your Java application scale more easily. By promoting loose coupling and flexible architectures, patterns like Singleton, Factory, and Observer make it easier to add new features and handle increased load. Scalability is crucial for modern applications, and patterns provide a solid foundation. Maintainability is a key benefit of using design patterns. Patterns help you organize your code, making it easier to update, refactor, and extend. When your code follows well-known patterns, future developers can quickly understand and modify it, reducing technical debt and long-term costs. Design patterns encourage code reusability. By solving common problems in a standard way, you can reuse pattern-based solutions across different projects and modules. This saves time and effort and helps you build reliable, consistent software. Extensibility means you can add new features or modify existing ones without breaking your code. Design patterns like Factory, Decorator, and Observer make it easy to extend your Java applications. By following these patterns, you can adapt to changing requirements with minimal effort. Design patterns can help you work with legacy code. By introducing patterns like adapter or facade, you can integrate new features or systems without rewriting existing code. This approach lets you modernize your applications gradually and safely. There are many resources available to learn more about design patterns in Java. Books, online tutorials, and community forums offer examples, explanations, and best practices. The more you practice, the more natural it will become to recognize and apply patterns in your own projects. To wrap up, design patterns are essential tools for Java developers. They provide standard solutions to common problems, making your code more robust, maintainable, and scalable. By understanding and applying patterns, You'll write better software and collaborate more effectively with your team. Keep exploring and practicing to master these valuable techniques. Congratulations on reaching the end of this overview on design patterns in Java. The next step is to try implementing these patterns in your own projects. Start with simple examples, then gradually tackle more complex scenarios. As you gain experience, you'll find it easier to recognize when and how to use each pattern. Happy coding!